All right, the next section we have is Stokes' theorem. Stokes' theorem for us is going to be a way to convert a double integral of the curl into the line integral around the boundary of S. Okay? So this is a tool. It can help simplify certain integrals. It's a big fundamental theorem in calculus. This is a result that's similar to conservative vector fields. We don't say the term conservative here, but it's more or less that same idea. And that is, if your vector field we're supposed to be finding the flux of is actually the curl of some other vector field, then the flux of F doesn't actually depend on the surface itself. It only depends on the boundary of S, what its opening is like. So we can replace F with the fact that we know it's equal to this. Now that we have the curl present, we can use Stokes' theorem for this equal sign to move it to this format. And then you can see that the flux of F only depends on the opening of the surface, the boundary, not the actual surface itself. And this also shows us that if our surface is closed, so think of like the surface of a sphere, it's closed. There's no way to go from outside to inside unless you poke through. So if you have a closed surface, then the boundary of S is empty. It doesn't have a boundary. So if this is empty, then the double integral over something that's empty is 0. So this is sort of like the same analogous result to if you've got a path that's a closed loop, and your vector field F, let's say, is conservative, then the circulation of a conservative vector field is 0. This is sort of the same thing.